I'm in a house in Vietnam that has no earth and one of the most shocking and mind-bending faults I've ever seen. Let me explain. So, I'm on my way to a bit of an adventure. I've got an electrician who follows the channel. He reached out to me when he knew that I'd be in Vietnam and he said, I've got some crazy stuff to show you. I think he's got a bit of a fault find on his hands, so I'm gonna see if I can give him some help and learn a bit about Vietnamese electrics. And here I am, and this is Ian. Nice to meet you, Ian.
Nice to meet you.
So where are you from?
America.
Okay, whereabouts?
US,
Yeah.
Florida.
Florida, oh, nice part of the world. And you're here in Vietnam.
Yes.
Doing crazy electrics.
Yes. There's a lot of crazy electric to be done here.
So, talk me through the typical electrical setup in a business or a house in Vietnam.
Okay, so you have your meters, which will be out on the pole. You'll have a breaker that serves each individual residence.
So that up there is the meter box basically, and then it just goes straight down and into the distribution board?
Correct.
Wow. My question then about these meter boxes though is how do they read the meter? Does somebody have to get up there with a ladder?
I've seen them with a stick with a camera.
Oh wow.
Yeah, they may have some smart meters now. I haven't seen any myself.
Yeah.
But at least in Da Nang, everything I've seen is still all manual.
And you have the crazy tangle of telephone wires, just like in Thailand.
Yeah, it's a lot of fiber optic. The way they'll run fiber optic is they'll take a brick, tie the fiber optic to it, and just walk down the street and throw it over the bundle of wires until they get to the house they need.
I like the way that those cables are coming out there. No grommets, no glands. Let's have a look inside, but first, I want to know about this. Is this your electrician mobile? Is this your van?
This is my transportation. Everybody in Vietnam uses motorbikes, so the hard part about working on electrical stuff or anything that requires tools is this is what you have to bring your tools with you.
We'll do a load out later and see what the difference is between tools here and tools in the UK. This is really fascinating to me because it's just so different to everything in the UK. And I'm intrigued as to how it all works. So let's have a look inside a distribution board in a Vietnamese shop. Okay, so this is the distribution board.
So yeah, this is a service entrance.
It's like an ice cream factory or something, that's right?
Well, bakery.
It's what
bakery.
it is.
Yeah, it's going to be a bakery.
Yeah.
But just a typical shop house in Vietnam.
Yeah.
You have a shop on the first floor, people live on the second and third floor.
Is that cable that comes in the side, is that the main feed?
No, the main feed is coming, looks like up from over here.
And what kind of size cables do they use as the main feed?
Looks like, what is that, 6 maybe?
6 mil.
I'm American, so I'm not really.
Oh, so you call it number 6 or something?
Well, no, I would call this like a number 10 in the US.
Okay.
It follows the same wire sizes as everywhere else in the world but the US.
Of course. I just like to throw a spanner in the works, you guys, don't you? Shout out to our American viewers. Leave us a comment below if you're viewing from America.
There are real no color codes here. Nobody follows color codes. If you notice, they got the red on the neutral here, the blue for the line here, but coming out of this breaker, which is fed from this breaker, this is the main, this feeds the second floor, we have the blue tracer that is also a line going upstairs. But here we have a blue tracer feeding the neutral. There is no bonding here, there is no ground, it's just strictly neutral and hot. You never know what you're going to get. Anytime you open up a panel here, sometimes it's a nightmare, and sometimes it's actually nice.
That's why you're here, right, isn't it?
Yes.
Because you got called because there was a fault?
I got called for this breaker tripping. It would trip after about 20 seconds of being on. This breaker feeds the panel upstairs, which we can go look at, and that'll be pretty interesting.
Okay, let's have a look at that then.
Okay.
Right, so we're here upstairs. Wow. Check that out. You've got to love a bit of twisted wire. I've seen so many wires twisted together in Asia. It seems like a national sport that they love to just twist wires together. But why? The question is why.
I don't know.
You can answer it.
The boxes come with a neutral and a ground rail, but for some reason they like to twist stuff.
So they're just going, we don't need that, we can just twist them together.
Twist them together. You know, no, they won't use wire nuts, won't use wagos, won't use, a bus. They just twist stuff together.
Let us know in the comments if you like to twist wires together. I mean, I guess there's this weird thing about it, whereas formally trained electricians, we just know that it's kind of wrong, like in our heads, it's wrong to do that. And yet I've been to countries where they do that and they actually solder them as well. And it is actually technically probably a better joint than a screw connection because it can't come loose, right? But it just feels wrong and so difficult with fault finding. I mean, how are you going to untangle that now?
So what happened here was the breaker downstairs was tripping. It feeds this panel. I shut all the breakers off, turned this breaker on, and it tripped. This was the jumper that's feeding your other branch circuits. So I assumed that was the hot, pulled that wire out, and the other 2 wires that were into the assumed hot side of the breaker, reset the breaker, and it tripped again. Turns out, the red wire here, which goes to our neutral bus twist here, they actually wired the hot to the neutral. So what I assumed was the hot, they were really switching the neutral on all of these branch circuits. Turns out there's a ground fault on this branch circuit here that's tied with this breaker. It was such a good fault where I would get 60 amps of current to ground and trip the breaker.
There was reverse polarity basically, so that they'd swapped the live and neutral at some point. So this bus bar here was the neutral bus bar rather than the live, and all of these MCBs were switching the neutral conductor rather than live conductor. Now you say hot, don't you? Because you're from America.
Hot.
You guys are just so hot. And we say live or line. But it's the same thing. And it's just so confusing anyway, isn't it? The red is with the blues and the blacks.
And yellow.
And white.
And white and red. Yeah.
How do you get your head around this stuff? I mean, how long have you been living and working here?
8 years.
Wow.
8 years.
So do you kind of get used to it, or are you still like...
You can't assume anything like I did here, where I assumed that this was the hot.
Yeah.
What everybody uses here is the lighted screwdrivers to check for hot and neutral.
Oh yeah, those.
And
the old death sticks.
Yes.
Because there's no earth wires in this, so somewhere there is a connection between this neutral, somewhere in the final circuit, and physical earth, whether it be an earthy piece of metal somewhere or something
concrete.
like that.
I get a lot of calls for nuisance tripping when it rains.
Yeah.
A day later, the rain stops and the tripping stops.
Magically, the fault disappears. Okay, so what is the mission then? What do we need to do today?
So it looks like this wire. This is a 3-story house. We're on the 2nd floor.
Yeah.
It looks like this goes up to the 3rd floor, and it's a finished ceiling with no access to the wiring in the finished ceiling.
Of course.
I'm back today to see if I'm going to retrace my steps, see if there's something I missed. But yeah, I need to find where this is connected to earth, because it's, yes, it's not going to trip a breaker now because it's not a short to ground, but now we have a parallel path to ground. And if we get an open neutral feeding the house, this becomes the neutral for the house. Can start a fire, can electrify, could electrify the water pipes if it's on a metal water pipe. But yeah, we can go through and look at some outlets and see what we find.
Okay, let's do it. So Ian was just saying to me that obviously in Asian culture it's polite to take your shoes off when you walk into somebody's house or a building. Even shops, often you take your shoes off, right?
Yeah.
However, there's a slight safety issue with that potentially if you're an electrician, right? So you very, very nicely ask our permission to leave your shoes on for customers, which I have also done. Okay, so this is the tool bag tour. So what are your go-to items that you use the most?
Fluke.
Yeah, nice.
Fluke. I got a
multimeter.
Unity amp clamp.
Oh yeah, okay, that's interesting because it's Unity, but that looks very similar to the TIS ones that we use back home. Oh wow, you've got a lockout kit.
A lock and some tags and breaker stuff if I need to lock stuff out. Wire strippers.
Oh yeah, classic.
Stake on crimpers.
Good,
This is an actual good crimping set.
Nice.
Crimping ferrules.
Oh yeah.
Ferrule crimper.
Are they the Mr. Quality ones from Amazon?
Yeah.
I think I've got the same, or Perceiver or something.
The bladed screwdriver. The band screwdriver that
is the
definitely need here.
Yeah, these are sort of renowned for DIYers or, you know, dodgy people to use. But actually, when you've got, when you really need to know if it's a live or a neutral, then that is quite an easy way of knowing.
And here, all the local electricians, if they go to do wiring, for whatever reason, they do wiring hot a lot of times.
Yeah.
And since there is no color code, they'll just use this to find out which wire in a box is the hot and the neutral, to find out which one to switch.
And that is more precise than like a volt pen, because
the volt pen will go off.
Exactly, yeah.
Here's neutral, and then there it is on the line.
Yeah, there we go.
And it will light brighter if you don't have shoes on.
Yeah, because it's using the resistance of your body, basically, isn't it?
Yep.
Have you ever had one fail or anything?
No. And I think they measure like 20 mega ohms, which is what a voltmeter measures across.
There you go, guys. Death stick, link in the description below. Do a lot of people die from electrics here? Like, do you hear about a lot of accidents, or more than you did back in the US, for example?
No. And not even fires. I mean, every once in a while you'll read about a fire that was caused by electrical. I have done work where, you know, a panel got wet and, you know, burned up the panel and had to fix it. The wife, she's Vietnamese. She is deathly afraid to plug or unplug anything.
See, this is the thing. I think that is actually the key, right?
They're scared of it.
It's a respect for electricity. Right. This came out in the video that I did in Indonesia on the island. There was this crazy...
Yeah, with the bare wires.
Yeah, you saw
kids. Yeah, and the kids running around.
Yeah, and people said in the comments, they said, there was quite a few Asians there in the comments, and they said, the thing is, it's like drummed into us from a young age, don't touch it, you know, be careful, stay away from it. Right. And I suppose that's the thing, isn't it? It's like simple, but it's kind of common sense if that's what you were taught.
Right.
Whereas in the UK and maybe the US, we have this kind of like culture of wrapping everyone in cotton wool and it's like idiot syndrome, right? Assume everyone is an idiot and is going to try to electrocute themselves. And then do everything possible to make it impossible for them to electrocute themselves. And okay, it's good because it must save lives. But it's just interesting to see in the kind of the opposite scenario how it's not as disastrous as you might actually think.
Right. The other good thing is just about on every corner there's an electrical, like a hardware store.
Yeah.
So if you need a breaker, they have a breaker. If you need wire, they have a wire. If you need electrical tape, they have electrical tape.
Cool. Well, let's get stuck in, eh?
You're an electrician, so.
Okay.
I'm looking for a second.
What I'll do is yeah, it's definitely live. So we've got 3 amps on the neutral.
And the circuit that feeds it, we have 3.7. So now the only thing connected is this breaker, which is disconnected. We have 480 milliamps of earth leakage.
So basically somewhere on the other end of this wire, there is a connection to an earthy piece of metal or ground somehow. It's leaking through, presumably through the main neutral from downstairs, through this, and then down to earth. And that's what we need to find. If I'm tracing it, what I'd be thinking is, okay, where does that wire go? So this wire here is the one where the fault is. Now it goes into a conduit in the wall here. So is that the standard way that they wire stuff here, basically? Flexible conduit buried in the walls, and then...
A lot of times it's just like oval sheath in the wall.
Right.
Like all your walls are brick, and after the brick is done, they'll go in with a chipping hammer, and they'll chip out paths for water lines and electrical lines. It's not common to see conduit.
So this is like a high-end electrical installation.
This installation is a little on the upper end, and I'm surprised to have the problem we're having, and not to have the wire and the colors to be swapped and switched and moved.
I've got a gift for you. I don't know if you've seen these before. Unilite make these insanely powerful head torches. There you go, it's a little gift from the Artisan channel. And if you guys want to get one of these, you can get a cheeky discount using our special code, link in the description below.
But yeah, here's kind of stuff to see. This is why I use a screwdriver, because if before we were switching to neutral, we would think it's de-energized. And it's not. literally into the brick wall. No conduit, no nothing.
Wow.
And there is no standard where it's going to go down and 8 inches off the floor, run across the floor. It could go from here over to there, over to there. I just want to verify we still have a current flow on the neutral.
Okay.
And I'm going to check. Since we don't know what is earth and what is neutral and what is hot, I'm going to have to check both phases for any current. I have no current on that one.
Would it be a radial circuit here, basically? So just in and out?
Yeah, no, there's no ring circuits that I've ever seen.
Yeah, but I guess they might just branch off all over the place.
Yeah.
Like, it's not just going to be a linear radial, but it'll be, you know, come to here and then go to 2 other places and then go to another place and then,
Right.
yeah.
So our earth leakage is not associated with this wiring.
Yeah, okay.
And here, we'll use a double pole breaker for water heaters.
Okay.
So people turn the water heater on 10 minutes before they need to take a shower. A lot of times you don't have hot water at the sink, you just have hot water at your shower.
Yeah, local.
A lot of local people will turn it off before they shower so they don't get shocked.
Wow.
Of course, all the newer water heaters have RCDs built into them, but the older ones don't, so you can actually turn this on. And you asked me before about people dying. Yes, there have been people who have been electrocuted by the water heaters taking a shower. But we'll go on the 3rd floor after this, and I can show you the water heater. And
Rub mark. Oh yeah, just wow, where it's nicked into the side of the box or something.
Right.
Boxes are all plastic though, right?
Yeah, they're plastic. We got nothing on that one.
So those smaller wires are the lighting, so they basically spurred off of the isolator for the water heater with smaller wires for the lighting, and they've also wired a socket off of that.
Yes.
So mad.
And we got something
And
spliced
some
in.
nice twisted wires there as well, just to add to the fun. Okay, yeah, so it's almost like we would have an electric shower actually, but the pipes are just extended to the shower there, basically.
Correct. And this one is actually protected with an RCD.
Wow, what a treat.
Yeah.
That's quite a chunky RCD, that as well. It's wider than, like, we would usually have a 2 module. This is almost like a 3 module. It's just a type AC though. 61009, yeah, it's pretty standard. And then this is what makes me laugh, is that you know that this washing machine right here, which is probably going to pull about 13 amps, is going to be wired off of that socket, which is actually wired off a bit of lighting cable. Yeah. Oh yeah, it's just completely open, and it's been overheating definitely there. They've always been overloading it slightly. Some nice twists there.
On the 3rd floor, this is the drop ceiling, and then I'll show you back here. There's a way to look up there.
Ah, okay.
I can't fit through there. So I could see some wires running around, but I can't see like a junction box where that red and blue wire come up.
Where would you start, guys? Let us know. What would you do in this situation? I mean, Ian is, you know, doing a favour for a friend here, basically, and it's kind of like, how far do you go at certain points?
So what would you do?
Run. Just run. Go back to the US. In my hotel room where I'm staying, the LED lights glow even when the switches are off. You've probably come across that a lot here. I've seen it rarely in the UK, and it's usually an issue with like earthing. What would you say is the problem there?
They just light with just the capacitance, you know, which is the neutral wire.
Yeah.
It's just, they just light on so low current, it doesn't take much to turn them on.
Yeah.
And it's probably, it could be a switched neutral, so it still has the power.
Yeah, that's what I was thinking. It might be something like that. So dodgy. Because the live and neutral was swapped around before, and they wire up the switches, you know, with their volt pens. Now that he's swapped everything back to how it should be in the mains, possibly all of these switches are switching the neutrals now. Potentially cause for the issue, because you've got a lot of metal light fittings here, like there's one in the bedroom, they're big chunky metal light fitting. Could cause a little bit of earth leakage, especially if it's screwed into something that's a little bit earthy. We're going to turn the breaker on, and then just check a few light switches. Actually, have you had any bad electric shocks out here? Or is that a no comment?
I've gotten shocked, yeah.
What's the worst thing that you've seen when you've been out here?
I mean, I've seen the tops of breakers where it's totally burned off because, you know, loose connections. I mean, you know, this is pretty bad. This is the first time I've come across the neutrals wired to the lines or wired to hot.
That's, yeah, one of the worst things really, reverse polarity, isn't it? It's kind of
yeah.
pretty, on the level of not serious to very serious, it's pretty high up there. Ian, if you don't mind me saying, you've got a pretty cool life really. Ian's life illustrates the possibilities of being an electrician because he basically lives over here and it's like super cheap to live here. He was telling me like $250 a month, you can get a nice apartment, scooter is really cheap, fuel is really cheap, costs like $3 a week for fuel.
$3 a month.
A month for fuel. So he lives here super cheap, then just hops over to Antarctica to just do a bit of electrics in Antarctica, because why not? He fancied exploring Antarctica, so might as well do that and get paid for it.
Yeah.
Or hop back home to Florida, do a bit of work on the Space Center for a couple of months, earn some cash, then live here for a couple more years.
Yeah.
Not a bad life. A reason to become an electrician, or if you were an electrician already and you're getting bored of the UK or the US, why not look into a bit of travel? You never know what you might discover. So the plot thickens a little bit because the light switches all seem to be okay still. Well, that one it does. I mean, we should probably check a couple more, I guess. It seems to be okay. Oh, it's nice and cool in here with the air conditioning. And this is why you should always wire sockets and lights on separate circuits, because it just makes fault finding an absolute nightmare, because you're not just checking sockets now, but you're having to check lights, and then you can't access all the lights. So it does show that there is a little bit of wisdom in the way that we do things in the UK. Just a little bit. This is the permanent live coming in.
Correct, to a yellow.
And it jumps across to the yellow there, and then that's the switch live going out, yeah.
Sometimes it gets confusing.
So calm. Sometimes it gets confusing. I would be tearing my hair out, I think. Like, no wiring colours whatsoever. There is no logic to this at all. It's pure chaos. And yet you manage to keep your cool and do this day in, day out. Respect. Respect. So the next steps really is like to dig a little bit deeper into the actual readings to see if it might be acceptable to leave it as it is. And Ian's done a low resistance ohm meter test from this down to there, because this little bit of concrete here is about the best you can get in terms of an earth connection, because as we said, there is no earth or ground in this board at all. So he did a test there and he got like about 2 megohms, which technically, if that was an insulation test reading in the UK, it would pass. But that's a low resistance ohm meter test, and what we really want to do is an insulation resistance test. So Ian's going around now just unplugging everything, make sure that we're not going to fry anything that's plugged in, and then we're going to do a insulation resistance test with this Unity gadget here and see what we get. So just to explain what's just happened there, Ian's just done a voltage test between this neutral and the main neutral there, just to see if there's any voltage, and then this neutral to line. Now he only got 8 volts between this neutral to line, which kind of indicates that maybe there's an issue with an appliance that was plugged in and now it's been removed, the fault is gone. Let's have a look.
Before, when I did it, I was getting 230 volts, 220.
Right, okay, interesting. It makes no sense. Could it be that the lead wasn't clipped on properly or something maybe?
Yep. That's
okay, there we go.
Crappy lead.
You know, always check your test equipment, guys.
That's not a ground rod, that's just a concrete floor. I'm getting less than 2 mega ohm.
It's just crazy, isn't it? It's just a whole different level of fault finding when you don't have a true reference to earth to actually measure to.
This is off, everything's unplugged.
I'd love to know from some of you guys if you deal with this stuff like day in, day out, and if you've got like really easy and simple methods to fault find this kind of stuff, because I guess you must get into a rhythm of it eventually and know how to do it, but I just want to run away. Like normally in the UK, I would say the obvious culprit for this fault would be something that's plugged in, because everything that's plugged in has an earth connection, it's got an earth pin in the socket, and therefore the short might be within the appliance, which often happens, or a dodgy extension lead or something like that, but not here.
No.
Because there is no earth.
Correct.
So even if you've
It
unplugged
would have to be an
everything-
appliance that has a earth fault on concrete.
Yeah.
But what I got now, if I measure from line to neutral on our problem circuit, I get that 1.4 volts. Line to neutral, I still get, just about line voltage. And resistance-wise, we had 250 ohms before, and now it's like 400K.
So you've definitely removed.
So there were some loads on it before.
Yeah, there were some loads. Removed the loads. So I guess the interesting thing now would be to check that leakage current to see if it's gone down at all.
Sure. 66 milliamps.
Still have the same.
So with everything off, everything unplugged, we have a problem on this neutral somewhere that we cannot find.
Did you test this with everything else turned off as well?
Yeah. If you want to turn all this stuff off.
Yeah.
Yes, 540.
There's slightly less, but still, very similar. There's no cross connections. That's what I was thinking, maybe cross connection between two circuits or something. But it's one of the most frustrating things as an electrician, because probably one of the most satisfying and enjoyable things is finding and fixing a fault. It's just like the jubilation that you get when you found it and you fixed it, and it was difficult, but you did it. It's like, there's no better feeling, right, Ian?
That's why I do it.
Exactly. It's sometimes good to have a second pair of eyes. But the power of YouTube is that we're now going to have 10, 20, 30,000 more people looking at this, and maybe they will have ideas. So when this video goes up, we'll check the comments and see if there's any ideas. So if you ever want to level up your fault finding, come and work with Ian for a day. I've certainly learned a lot. How about this, right? Ian's got a YouTube channel. I'll leave a link to that below. Go and follow Ian's YouTube channel, and we'll get him to do an update if he finds the fault. We hope that you guys have enjoyed this crazy fault find. It's certainly bent my mind a little bit. I think I'm ready for a cold beer now. But thank you for watching. Thanks so much to you, Ian, for showing me around.
Thanks for stopping by and letting me show you the crazy stuff you see here.
Yeah. And if you want to watch more crazy fault finds, there'll be a video here of me exploring a crazy fault in a house in the UK, and there'll be another fault here, and I'm not going to tell you what it was, but it was really, really shocking and interesting. See you all on the next one.